Data Voyagers.
Hello, Data Voyagers. Welcome 2026. I mean, if you're watching this as we record it and launching. Um, and let me tell you what, we have a lot of things, great things planned for you this year. We'll talk about that in a minute. But before, let's talk about the episode today. In the episode today, the title is very interesting. Data is not the truth. What? Um, well, we live in a time where data is everywhere. We know that. We measure everything, we store everything, we visualize everything, and yet somehow we still get surprised by the outcomes. Projects fail even though the numbers look good, decisions backfire even though the dashboards were green, predictions miss reality even with sophisticated models behind them. So data is not just the answer. Hello, Data Voyagers. I am Igor Alcantara. Oi, pessoal. I was missing saying that. And as always, I'm joined by my brilliant, amazing, super nice person, my co-host and friend, Angelika Klidas. Angelika, Happy New Year. I think we still allowed to say still January. Thanks for being here.
Hoi Igor en hoi allemaal. Fijn dat jullie er allemaal weer zijn. It's great to be here again, Igor. I have a little bit of cold, as you can hear, but the whole house is a little bit sick. But yeah, I'm happy to be here, starting to record again, talking about interesting topics that can help everybody to understand more about our amazing data world. Find that story behind the numbers.
Exactly. So before we start the episode, let's talk about 2026 a little bit. I assume getting used to it's not 2025 anymore, 2026.
Mhm.
It's like I'm talking from the future. But anyway, let's talk about this year, what we have planned. So we're starting the podcast now. So we still have the podcast going, right?
Mhm.
And what else? You think? And by the way, this can change. We can add more stuff because the word is dynamic. But what do we have planned for this year so far?
Well, we have the two weekly podcast recordings. Of course, we will invite some guests. We will discuss interesting topics. We will actually definitely will be at Qlik Connect, right? To do some shows from there. And we are working on some cool stuff. Um, thank God we will also have Lund this year again. So I hope we will have the ability to talk to some interesting people again. Have good conversations. I know you are writing like crazy at this moment from the so that can be put down on the Data Voyagers website. We have super interesting swag. So yeah, I know 2026 will be an amazing year. Yeah.
Exactly. So I agree. We are definitely going to Qlik Connect.
Mhm.
So the whole team, which is so far three people, you and I and Mark Costa, we bring in a lot of equipment, two cameras, maybe three cameras. I don't know. Let's see how much we'll be able to carry, and microphones and everything. So we will do a lot of content there. We don't have all the agenda yet for what we are doing. So once we have it, we'll let you know. And one important thing is you help us to grow. Go to our blog. There's something you like, and there's a lot of things in our blog. There's something you like. Share it with people. Subscribe to our YouTube channel, to our podcast. Either if you use Spotify or if you use some other media like Apple Podcasts, Overcast, whatever you use, Amazon Music. We everywhere, so you can subscribe to our podcast. That helps our statistics. Go to our store. As Angelika said, we have interesting swags. We have a lot of like t-shirts, like funny data related, IT related t-shirts and mouse pads and stickers and like a bunch of things. And we adding more stuff. And pretty soon, like in the next week or so, we're gonna also have an Instagram page that will let you guys know, so you can follow us on Instagram as well. We'll do some content there. We try to do like short videos and stuff like that as well. And LinkedIn, it's still our main social media. So go to LinkedIn and search for Data Voyages. Make sure you follow us. So there's a lot of things going on. If you follow us, then we'll let you know. And if you go into Qlik on that and you find us there, talk to us. Let's take selfies. Let's have conversations, and post them, and they'll be nice. And we even considering bringing a few swags to give out to people. Maybe we do a ref or something. I'm not sure how much swags we will be able to bring for people who follow us. So, but we'll have an episode about preparation to Qlik Connect before Qlik Connect, of course, because after doesn't make any sense. But there's a lot coming this week. Angelika will be in a couple of panels. I'll be presenting a session. We're doing like content live at Qlik Connect. So if you're going to Qlik Connect, meet us there. If you're not going, try to go. It's an amazing event. Let's head
today,
go. Yes.
Today, what are we going to do today? We decided to have a series, right, of 2 episodes about amazing important topics.
Yeah, so there is one of the most important episodes that we recorded so far, and because there is so much content, we realized, well, we need to break this down in 2 episodes, because we initially thought about doing 1 episode, but it's so much content, and we don't want to be too long, so we do the first part here, and the next episode 22, you get the second part. But it's all part of the same topic, which is contradictions in data. You see the numbers are correct, I validated them, but the conclusions we make sometimes are not. Because the problem is not we're missing data, the data is wrong. The problem is that we misunderstand what the data can and what data cannot do. And this episode is about that, the fallacy of data. Not a single mistake, but a collection of beliefs that quietly distort how we analyze and interpret trust number. But before we begin, let's just hear a quick word from our sponsor, IPC Global. This episode is sponsored by IPC Global. IPC Global is a data analytics and data science consultancy with almost 30 years of experience helping organizations work with data in a way that actually supports better decisions. They have been Qlik Elite partners for over 2 decades, working closely with customers across industries to turn data into something reliable, available, and usable across the organization. But IPC Global's work goes beyond building dashboards and pipelines. Their expertise sits at the intersection of data, research, and decision-making, helping organizations not only access data everywhere, but understand it, question it, and interpret it responsibly. That includes spotting bias, avoiding analytical fallacies, and using data as a tool for thinking rather than something to blindly trust. If your organization wants to move from having data to actually making better data-informed decisions, IPC Global can help. You can learn more at ipc-global.com. And now, back to the episode. So, Angelika, let's start the episode. And data, it's not everything, right? Data do not speak, right?
No, that's one of the biggest illusions in analytics, is the idea that data should speak for itself. It does not. Secondly, it's silent. People give it a meaning, and that's what we do, right? And most importantly, we need to know how to read it. A few years ago, I had the honor to interview Night Chair in journalism, Alberto Cairo. He wrote amazing books about architecture, but also a book about how charts can lie, right? And he used a phrase, a piece of text in his presentation, in his discussion with me, and I always use it in my trainings. He said to Angelika, the common misconceptions when you talk about data visualizations are that a picture is worth 1,000 words, or that the visualization is intuitive, or that the data speaks for itself, and that we only have to show and not tell a story. And his answer, yeah, well, if you know how to read it. So, what basically everybody needs to understand is that every data set is the result of decisions, right? We need to know what we collect, what we put in, what we do not put in, so what we exclude, how to define events, and how to measure success. And before any chart exists, interpretation already has started. And if you look at those elements, we have all kinds of biases included in the work that we do. And confirmation bias is one of them. So when analysis becomes a validation, a short example about confirmation bias. So a company believes that their new marketing campaign is successful. They collect data from 3 different sources: social media engagement, website traffic, and sales. And when that they see that the social media engagement increased with 20%, they celebrate and they say, "Ah, the campaign works." But they ignore the fact that website traffic actually decreased by 15% and sales remained flat. So everything is interconnected. And they cherry picked data in this case that confirmed their belief. So the engagement went up and downplay or ignore the data that contradicts it, like traffic and the sales that didn't change. So that's a good example of confirmation bias with data. We selectively look at the numbers that support what we already believe, while ignoring or dismissing the numbers that suggest we might be wrong. So, so let's continue a little bit further and explore confirmation bias a bit further, because it sits at the root of many other fallacies or thinking errors. I had to actually look that word up, fallacies, uh, thinking error. We do like answers as humans. We like clarity, and most of all, we like to be right. Right, Igor?
Absolutely,
Yeah.
absolutely.
So what do? We approach data with a mental model already in place. We believe that a process might be broken or is broken. We believe that a product is successful. We believe that a decision was correct. So let me give you another example. Imagine someone believes that people who drive red cars or Volvos or Audis, uh, and they are more aggressive drivers. They always drive fast, go left, right. And because of this belief, people will notice and remember every time a red car cuts them off or speeds. They ignore or forget all the red cars that drive perfectly fine, and they overlook aggressive driving from cars from another color or from another brand. And they will feel that their belief is constantly being proven correct, even though they are only paying attention to the evidence that supports it. That's a typical example of confirmation bias. So confirmation bias can help you with an approach to deal with we can help you with a kind of approach uh, to deal with confirmation bias, with a mental model. We analyze instead of asking open questions, and we ask the leading ones. And there I think people will think about the fact, yeah, what is a leading question and what is an open question? Well, open question is neutral. It invites exploration. It says, tell me what you found. For example, what does the data show about the impact of our campaign? This question has no built-in answer. It lets the data speak. A leading question, on the other side, is loaded. It already contains the answer the asker wants to hear. For example, how can we demonstrate that our campaign was a massive success? You notice the difference? And the leading question assumes success and asks you to prove it. It's not asking what happened. It's asking you to confirm what you already believe that has happened. So we slice and we dice until the data agrees with us. and we stop exploring the moment we find confirmation. And in fact, this is not malicious. It's just human behavior. We try to make the numbers say what we already believe. We ignore when it contradicts us. And confirmation bias actually is one of the most dangerous situations in data analysis because it doesn't feel like a mistake. Confirmation bias happens when we approach data with a belief already formed and then use analysis to validate that belief instead of challenging it. So the fact is that we rarely say this out loud, but it happens constantly. We believe that a strategy is working. We believe that a product change was successful. We believe that a process is broken, and then we analyze. And then the analysis that we want to do is no longer a question; it's an argument, right? Confirmation bias begins before a single line of code is written or a chart is built. It starts with how the question is framed. Instead of asking, what is happening in the data? We can ask, can we prove that this is happening? And that mind shift changes everything. It determines which dimensions we explore, what type of filters we can use, which time windows we can choose, which metrics we can trust, and more importantly, which ones we ignore. I know, Igor, that you are also a believer less is more. It's better to show less than pack your dashboards full with information. Right?
Yeah, absolutely. Yeah.
Yeah. So one of the most common expressions of confirmation bias is selective slicing. And here's a short example of selective slicing. Imagine a city's mayor claims their new far of crime policy and enacted in July. So what I mean is the mayor says they have a path chosen to avoid crime in the city. And he says it's working perfectly. It's brilliant. And they prove it by presenting a chart that's showing a steady decline in crime rates. However, the fact here is that they only show the data for July, August, and September. So this selective slicing, and I call this cherry picking, is not a good thing because a broader look at the data for the entire year might show that the crime rates already dip in late summer and that the overall crime rate for the year has actually increased. So the mayor of the city has sliced the data to a specific time frame that confirms their belief, ignoring the larger context. And with selective slicing, we slice the data until the trend appears, and that's not a good thing, right? I remember I have a slide in my deck for my data visualization courses. I always try to use the bad visualizations, and I have one that is over a lot of years about temperature. The temperature that there is a how do you call that in English? That the temperature of the global warming, right? The global warming. Yeah. And if you pick only from 1996 until 2025, you will see that it's marginal. But when you look at it from a broader perspective, we can see definitely there is a global warming issue going on. And that's cherry picking, as I try to explain to my students. And we group it in a way that supports the story that we want to tell. We zoom into an exact segment that behaves as expected, that we want to show. And then at the end, when the data contradicts us, we call it an outlier. When it agrees with us, we call it insight, right? Do you
It's
want
like
to add
software
something?
developers. It's like software developers. If it is something that we knew, it's a feature. It's not a bug; it's a feature. It's always. But there is a very interesting example of confirmation bias. It's not only confirmation bias; there are other biases as well. Then there's a lot of dishonest on it. But when you have like investment funds, a lot of investment funds, they claim, oh, our portfolio gets, I don't know, 50% more than the SP 500, something like that. So we have great investment. We have like the geniuses, brilliant minds. But reality, nobody knows how the market will react. Nobody can predict if a stock go up and down. It's all a narrative. So what happens, I mean, honestly, unless you have insider information, which is a crime. But what happens a lot of times is like, well, they only showing the numbers at the end of the year. So before the end of the year, they drop all of the stocks or everything that is not profitable, and they report what they have on hand at the end of the year, which is, so it is not only cherry picking, it's like it's dishonest, but that's what a lot of them do when they say, our we have this profit margin of this amount of percentage. Usually pick a period, as you said, they pick a period where they were profitable. They ignore the ones they were not, ignore when they made a mistake. They only focus when they got it right.
Yeah.
So that is a confirmation bias. Sometimes, most of the times, confirmation bias, it's not intentional. It's just I want to believe something. Um, it's if I say every time I wash my car, it rains. Maybe I doubt it that the fact that I'm washing my car interferes the weather. But probably I'm only remember because I believe that, just like the car, the color of the car, I'm only remembering the times when I wash the car and it rained. When it does
Yeah.
not happen, I don't remember. Or a couple having an argument, and you might say, you never say sorry, you never admit when you're wrong. Well, you don't remember when the person do,
Hmm.
and then
Yeah, exactly. Exactly. Confirmation bias is something I believe that is uh, in our lives so many times. The story about the red car or the Volvo or the Audi. I always say Volvo drivers and Audi drivers, they are the speedy ones, the aggressive ones on the road. Uh, but that's confirmation bias, to be honest. But because there are people that driving normally as well. So that's a weird thing, right? And that we even have it ourselves while we are not working with data. But we have to be careful about that. When we want to say something, we should avoid that slicing element that we only take a part of the data because we have to tell a story, right? Um, so but also it comes up in hypothesis driven analysis, right? When a hypothesis becomes a conclusion. Hypotheses are supposed to be tested, not defended. Uh, and in practice, we often treat them as something that we want to protect, right? We look for statistical significance instead of practical relevance. Or we stop testing alternatives once one path of the testing works, right? Or we do not ask what else could explain the pattern. So the moment analysis becomes a defense mechanism, learning stops. And another subtle form of confirmation bias appears in a metric selection. We choose metrics that are aligned with our expectations. If we believe engagement increased, we look at clicks, right? Instead of other elements. If clicks do not confirm it, oh, then we look at the duration of a session on the website. And if that fails, we look at the active users on our website. So confirmation bias is everywhere, right? And eventually something will move in our search for the right answer in the right direction. So the metric actually did not lie, but the selection process did. Confirmation bias is also reinforced socially. So when analysis is presented in meetings, dissent is uncomfortable. Challenging a narrative means challenging a decision in this case. And challenging a decision can feel like challenging a person. So contradictory insight gets softened, uncomfortable charge gets skipped, and alternative explanations are. Hold on, something is popped up in my. Alternative explanations are mentioned briefly if they do it at all. So the result at the end is that there is consensus without any understanding. And one of the most dangerous aspects of confirmation bias is that it compounds over time. Um, like Early assumptions influence early analysis, or an early analysis influences data models, or data models influence dashboards, and dashboard influence decisions. Once this cycle starts, every new data point is interpreted through the same lens, and reality changes, but the narrative actually does not. And another aspect is that confirmation bias also creates overconfidence. When data appears to agree with us repeatedly, we stop questioning the data and we trust our intuition more, or we explore less, or we test fewer alternatives. I've seen it many times when people, oh, the number is good, so we don't have to look further. Guys, come on. This is what is happening in the organization. When a number is off, they don't start exploring uh, why things happened or ask the why questions, but they just assume, okay, well, it's bad. Let's hope it's next month it's better. And that's annoying, right? Because we have to learn people how to work with data and how to avoid confirmation bias. Even though the data says the KPI is red, you should be searching for the answer, the why. Right, Igor?
Absolutely. So let's talk about survivorship bias then.
Survivorship bias. Yeah, I think that's
Yeah,
a good one. Yeah.
yeah. So what is survivorship bias? And it's actually sometimes might be confused with some other biases, but it's like confirmation bias, but it is not, and is actually very very present in science research, in medical research, in a lot of
Mhm.
research. Um, and so survivorship bias happens when we study success and we forget failure. There is a lot of value in failure. If I do a study to find some evidence and I do not find an evidence, a lot of people just don't publish because they're ashamed. No, that should be published because it is a valid knowledge that A and B are not related. They're not a good path, so other people will not pursue that path. So we analyze high performing teams, but we ignore the ones that dissolved. We look at retained customers, but we ignore those who churn early. We study companies that survive crisis, but we forget those who disappeared. So the data set looks complete, but is already filtered by survivorship, by reality. So what it's missing often matters more than what is present. If you think in terms of Qlik, um, survivorship bias will be only considering the greens and whites and forgetting the grays. The grays has a lot of
Oh,
value on them.
exactly. Yeah.
So when failure is invisible, success becomes misleading.
Yeah.
Um, and that's actually it's almost every single self-help and person a book and personal coaching training, all of those, or most all of those, they fall into this fallacy. For example, um, Mark Zuckerberg and Bill Gates, they both quit college and they become billionaires. Success, great. Follow your dreams. Quit college. No, hold on. The fact that they both quit Harvard tells a lot. If you in order for you to get to Harvard, unless you have, and by the way, great Qlik customer, um, unless you are like you have like some kind of scholarship, you need to have a certain uh, uh, level of like money, and you need to come from a certain background in order to get to that point. So getting to Harvard, uh, already indicates that you have certain family wealth history. So you might have parents or relatives that will be able to support your dream, support your business. You might not need to work for a few years, so you can invest in your company and things like that. So it's not like quitting your college and work. So a lot of those examples, we only focus on the ones who actually, oh yeah, people did this and this worked. But 99.9% of the cases when the same thing happened, it did not work. It failed. But we don't like we don't like losers. We don't like to tell those stories, but they are important. And that is the one example of survivorship bias. So survivorship bias is the fallacy of studying success and forgetting the failure, as I said before. And it happens when we analyze only what remains visible. We ignore what disappear along the way.
I remember a
So
story about that, right? We discussed it, I believe, this afternoon when we
yes,
were
that's a
preparing for the
classic.
podcast.
Yeah,
Yeah,
that's the
classical
classic
example.
classic
Yeah.
example. You want to explain that to our audience?
Well, it was about it's about the misconception of the bullet holes, right? In World War
Mm-hmm.
II, they did
Yep.
some analysis. I don't know the statistics exactly from my head, but let's say they studied 100 pilots, and only 45 returned, and the rest was either killed or taken prison because their plane fell down.
Mm-hmm.
And um, they wanted to perform a statistics to protect the aeroplanes, but where should they protect? And so they started to look at the planes that came back, and noted all the bullet holes an image of an airplane. And um, Mr. Abraham Walt, he was a statistician from Israel. He saw the fallacy in this issue. The issue was that they were looking at the things, at the planes that came back, not at the planes that were left there. So actually, it should have been turned around, right? And that is how they solved the problem with the
Yeah.
bullet holes issue. Yeah,
Yeah. So the place where they found the bullets, I mean, they're fine because the planes can take bullets there and still
yeah,
return.
and
So
still return.
reinforce every place without a bullet because we don't have any example of airplanes with bullets there that return.
Yeah,
Survivorship bias.
yeah,
Exactly.
exactly. Yeah,
And those things, they are easier to see than we assume that the whole story, like the bullets. Those are not all the airplanes, only the airplanes who survived. Those are not all the interpretership stories. Those are only the ones who were, successful and
successful
people
and
wrote books
famous.
about them.
Yeah,
We rarely write books about people who, like a loser. The guy tried this 10 different companies, fail in every single one, and die of cancer. We don't tell that story. There was no books about it because it's a sad ending. But those are important knowledge. So absence is not neutrality. Absence is lack of information. The absence is actually information by itself. So when
yeah,
something disappears, like when it churns, when it fails, when it drops out and shuts down, it often leaves no trace in the data set. So then we can analyze later. But we need to follow the trend to realize, okay, what actually stopped happening, and let me understand why. So that missing trace silently will end up, if you don't think of that, distort the conclusion. So let's say there's a classic pattern that appears in business analysis. Let's give an example. So we study high performing teams to understand success. So everybody, so these are the examples. Let's follow them. We analyze top selling products to identify best practices. Oh, we made this for these products and it worked. Let's do the same for all the products. We review retain customers to learn what keeps them loyal. And this is all good, all reasonable questions, but they're not all the questions. The fallacy emerges when we forget to ask the opposite questions. Why did some teams collapse? Why did team fail? Sort of blaming the people individually. Why did it happen? Why did certain products fail early? Why did customers leave before we even measure them? Um, so if failure exists in the system early, then success becomes overrepresented, oversampled. So privacy bias is especially dangerous because the data looks clean, the data looks good, the data is in fact correct. The data set is complete, there are no missing values, the charts look stable, but the cleanness in this case is deceptive. The data has already been filtered by survival. Everything that did not survive is already gone. In analytics, this shows up clearly in like funnel analysis, like the funnel
yeah,
chart. So we see that. So we analyze users who reach the final step. We compare conversion rates among those who completed a journey. We optimize based on the behavior of people who stayed. But what about the ones who left early? Let's say I have a survey that had like 3 steps. How about the people who do not finish the survey? They finish step 1 and did not complete step 2 or 3. So if the majority of users drop out before the measuring ever begins, the analysis explains persistence, not experience. We optimize for survivors and we ignore friction. So survivorship bias also affects machine learning and predictive models. Models are
Yeah.
often trained on historical data that represents successful outcomes. And successful doesn't mean something good. It could be like trying to predict a hospital infection. So that's a successful, quote unquote, outcome. Like approved loans, completed transactions, delivered projects. But the rejected ones, failed attempts, abandoned process, and missing or underrepresented. I remember there was a case many years ago in a hospital. We're trying to analyze how much time people stay in the hospital, in emergency room, how much time from the moment they check in to the moment they're first seen, to the moment the doctor sees them, and so on. So to analyze the whole stay of the patient. But if the patient comes in and leaves before being seen, we were missing that data. We're missing that data. Um, and those are very important ones because then we realized there was not a very small number of people. Then we had to like somehow capture that data.
Mhm.
Because a lot of modules they learn from winners only, and then we wonder why predictions fail once we implement it, once you put in production. Another subtle form of survivorship bias appears in performance analysis. We celebrate high performers and we analyze what they do differently and we try to apply them to the whole company. But we rarely study those who tried the same strategy and failed. We attribute success to behavior when in reality, we have things like luck, timing, and external conditions that might have played a larger role on that. When we only study survivors, we confuse correlation with merit. In data visualization, survivorship bias often hides behind averages. We calculate metrics based on entities that remain active, like active users, current customers, existing access, but churn users and retire access no longer contribute. So
Yeah,
the average.
I remember that the average, using only the average in our visualizations is also a bad thing. We should look at it from multiple ways. Like
Oh yeah,
that's what I teach my data visualization students. Like if you look at salaries, for example, if two people have an extremely high salary, and the rest of the staff has a more normal line in salaries, those two extreme values influence the values of the normal ones. So you always have to look at it from different perspective, from aggregations, right?
yeah, and actually, on that topic, we do have an article from November 2025 in our blog, datavoyage.net. It's called Measures of Center Tendency, a practical survival
Exactly.
guide for Qlik developers, where I explain all of that in detail
Yeah.
with how to do it in Qlik if you want to do it.
Yeah,
No,
great. But
pretty good article.
yeah, that's why I want you to mention it, my friend.
Yeah. So there's a lot of problems with survivorship bias. Like we underestimate risk, we overestimate repeatability, we ignore fragility, and the system looks stable until it's not.
Mhm.
But there is an antidote to survivorship bias, and we always talking about these biases, and we're talking about the antidote, how we avoid those. One is curiosity about what is missing, who is not in the data, what disappear before measurement, what failures are invisible. So sometimes the most important data set is the one we do not have. And survivorship bias teach us a critical lesson. Success is not always informative, failure often is. And when data only shows us who survived, it's not telling us how the system reality works. It's only telling us who made it through. So that's survivorship bias. it is a very important one. Now, there's another one that actually it's pretty common, right, Angelika, about
Yeah.
authority.
Yeah, authority bias is also one that comes up a lot. We tend to automatically believe people who seem to be in charge that they know a lot. Think of a doctor, think of a teacher, or a boss, and we always tend to believe them, and that is called authority bias. It's a problem when we trust those experts so much that we don't think of ourselves. So we might follow their advice even when it seems wrong, just because they are the authority. I see this happening in culture land uh, areas like in Greece. A doctor, a white coat, has a lot of power. He's believed. People always say yes and amen to them, right? Instead of asking questions and so on. So it's like doing something because the boss said so without stopping to question it. Um, and as I said, the white coats are an important person in Greece, where a big hunch of my family lives. And a patient goes to a doctor and complaining about back pain, and the doctor says quickly, "Oh, you need a surgery." And the patient does not ask questions or seek for a second opinion. That's what I would do anyway. And they simply trust the doctor because the doctor is an authority figure. And later they discover that physical therapy would have solved the problem without surgery. And that is exactly my point of authority bias. The patient believed and obeyed the doctor without thinking critically, simply because the doctor seemed to be an expert. Um, so, when we look at authority bias, not all charts are judged equally. A visualization shown by a senior executive could carry more weight, or a report from a well known consulting firm feels more trustworthy. We see it happening all the time, right? If you talk about AI adoption and the report is from Gartner, well, everybody follows because Gartner is the name. But then we have two specialists here about AI adoption as well in this room, not in the same room, but in the same virtual room. Um, a metric coming from a branded platform feels more official. So, but authority does not validate analysis. Bad assumptions remain bad assumptions, no matter who presents them. When authority replaces curiosity, fallacies survive unchallenged. And authority bias is the tendency to trust data more because who presents it, not because of how it was analyzed. So a chart coming from an executive deck feels more credible because it's from an executive deck, or a report like from MIT or Gartner. It's a well-known consulting firm. It feels more reliable, or a dashboard coming from an official system feels final. And because of that, we stop asking questions. Authority bias is dangerous because it silences doubt. When data is presented by someone senior, experienced, or highly confident, challenging that analysis can feel uncomfortable. Not because the logic is sound, but because the social cost of questioning it feels high. And everything remains untested, or unchallenged, or ignored, or not examined. And that's a weird case because we have to be critical in the things that we do, not only when it comes to data, but also from the output from generative AI, for example. And the antidote to authority bias is quite simple, but it's very uncomfortable. We have to treat every analysis as questionable, regardless of who produced it. We have to ask how the data was collected. We have to ask what was included. We have to ask what assumptions were made. So good data cultures do not reward agreement. They reward thoughtful challenge, because authority should never replace understanding. And the next topic is availability, right? And anchoring. So let's get started. Availability bias is our tendency to judge how likely or common something is based on how easily it comes to mind. If we think of we can have many examples of something, and we assume it happens more often than it actually does. We rely on what is memorable or recent rather than on actual facts or statistics. So a short example. Um, After seeing several news reports about plane crashes, a person becomes afraid of flying and thinks planes are very dangerous. However, statistically, driving a car is far more dangerous than flying. The plane crashes were memorable, right, and vivid, so they seem more common than they actually really are. That is availability bias. The person judges the danger based on what they easily remember, not on actual data. So regarding our stories and about data and insights with data visualizations, what happened last week feels more relevant than what happened last year. Or a sudden spike in a visualization feels more meaningful than a long-term pattern. What do we see in the data? Or a recent incident feels like a trend. And recency becomes a shortcut for relevance. Anchoring bias reinforces that effect. Um, so maybe you can add something about it because I think I can talk for hours about this, Igor. So let's shake up the things a little bit. Do you want to tell something more about availability
Yeah,
bias?
so availability, and it's similar to some of the things we discussed, and we'll discuss, but
Yeah,
there's a few differences. Um, and Availability bias is basically our tendency to judge how likely or common something is based on how early it comes to mind. So if we
yeah,
can think of many examples of something, we assume it happens more often than actually does.
yeah,
We rely on what is memorable or recent rather than what actual facts of statistics. If I'm in the raining season in a place, I may say, "Oh, this city it rains all the time," or things like that. What is the most common color that exists in clothing? I might say, "Oh, it's black," because that's what I'm can remember. A lot of people wearing black, or because that's most of the color that I use. But in fact, it's blue.
hmm,
In reality, that's actually a true data. Um, so you have a very interesting example as well about that, right?
yeah, yeah,
Mm.
yeah. I think availability is um, it depends on what you look at. Just like indeed that example of when you see a lot of stories because they will be in the newspaper about airplanes crashing down, but actually driving that car is far more dangerous than flying in or being in an airplane, right? But those stories stick. It's like the train accidents that just happened in Spain. Uh, Once in how many years ago it happened, but because it's such big news, um, we could be more afraid of taking the train in Spain, right?
So I'll give you an interesting statistic. For a male in the US, it's
Hmm.
more likely that you get married to a Kardashian than you die in a car plane crash. It's a true statistic. So that's how rare these events are. But it looks like, oh, they're falling all the time, or there's an increase in trend. Not
Yeah,
really. It's just because um, it's not on the news when the plane flies smoothly with no incidents. It's on the news when it crashes. And most of the time, it's those small private planes that, doesn't do like
yeah,
the normal maintenance schedule and all of that.
yeah.
Um,
Yeah, and it affects us everything that we do, right? Because it distorts our analysis in various ways, but subtle ways. Like
mhm.
that signal that is just a temporary fluctuation or a short term anomaly drives long-term decisions, or that we see something first, but not what matters the most for an organization. So um, that narrative hardens early, and that's I think that we have to take care of. So we have an antidote for that in those biases in availability bias, that is deliberately slow down. Zoom out before you zoom in. Compare multiple time windows. Look over various periods of time. Look through various dimensions. visiting early assumptions once more the data or more data is available. So we can do things about it. And good analysis resists the temptation to let the first number win, right? That is what we have to do. Uh, and it's so easy to recall, but it's not always that thing that is important. Um, well, that's about authority bias, availability bias, I think. I think we have another important thing to go for this session, and we are already 50 minutes on our way.
Yeah.
And that's
So we can
sampling
do one
bias.
more bias,
Yeah, yeah,
and then we'll continue in the next episode.
exactly. Sampling.
So,
Wow.
so what is sampling? I'm not talking about DJing. Sampling in that case is like taking samples. And sampling bias happens when the data we analyze does not represent the reality we want to understand. The analysis might be correct, the calculations might be accurate, the visualization might be clear, and still conclusion is wrong because the data is not the world. It is only a slice of it. Sampling bias often appears when data is collected out of convenience rather than design. So, for example, we analyze users who logged in, customers who responded to the survey, only even if only 10% responded, transactions that completed successfully, but the population we care about is larger than the data we capture. Those who never engaged, never responded, never completed the process are missing. And missing does not mean irrelevant. This fallacy is especially dangerous because it hides behind technical correctnesses. Dataset looks complete, there are no missing values, the model runs smoothly, but the sample itself is biased. We end up answering different questions rather than the ones we think we are asking. And another form of sampling bias comes from voluntary participation. People who opt in to answer a question, to answer a survey, they're not random. They are usually more engaged, more opinionated, more motivated. When we analyze only those voices, we mistake enthusiasm for consensus. So
Yeah,
sampling bias create, in that case, false certainty. It
yeah,
reduces apparent variability, smooths reality, makes system look simpler than they are. And there are so many ways. A good part of my work, and sometimes even out of my work, I do, help friends who are like in research. I help a lot doing like experiment design. Like, so you have an experiment, you have a study. Let's design that. How you sampling? How we doing that? So I do it, and I love doing that work.
mhm,
And there was a friend in Brazil. She was studying national parks in Brazil a while back for her PhD, and I helped her design the experiment. And one thing she said, "Yeah, I'm going interviewing the people who visit the parks." And I said, "Yeah, that's great, but that's not what you're trying to answer. That's not your research, because you're not interviewing people who does not. And secondly, when are you going? Oh, I can only go on the weekends and holidays because I'm in class the rest of the week.
mhm. There we go.
So then we have a problem because you only interviewing people on the weekends, but there are people who go to the parks during the week. Oh, actually,
Yeah,
no, I'm sorry. It was the opposite. She was doing classes, so she was going during the week. So people who go to the parks during the week, they either like retire, they don't work, or and there's a very small population. Most of the people they also go in the weekends, so you have to include the weekends. You have to include different seasons during the year. You have to include different time because the people go in the morning, people go in the afternoon. And also keep in mind that people who go in the morning, they're in a different mood than people that go late in the day. Um, Actually, I'm working in a medical study right now where interviewing people about self evaluation, and I said, well, they will self evaluate them better if you ask them in the morning than at the end of the day. So
exactly.
you need
Or
to
end of
have
the week.
both
Yeah,
end of the week, that kind of stuff. So we need to because Friday everybody's in a better mood. The answer would be different if you ask the same people on Monday.
yeah,
So we need to spread out. We need to consider that. Um, that is part of the design because if you don't consider those factors, or even when you asking, where are you asking? Oh, I'm asking in a mall. People about like who they're gonna vote. Who goes to a mall? It's a certain audience, a certain age group. Um, and so you need to
yeah,
consider all
yeah,
of those. Like Um,
Even in this book, there is a very nice example. This is the book Invisible Women,
mhm,
written by Caroline Criado Perez.
mhm.
It's about data. And one of the facts that I was reading about here is that all buildings that are built are heated for a male person of 40 years old. And that is why we women always have it cold. So that's also a typical example of sampling bias, right? Not having the correct amount of data in, the correct amount of separations, women, ages, men, ages, and so on. And the same, I wrote this, I have was reading a study about the first inhabitants of Canada, uh, that when they go for medical help to a hospital, the treatment sometimes didn't work out because the research was done on the male Western persons, right? So there is a difference there, and that's where the sampling things go wrong. Sampling, I think, is one of the most important elements in statistics, in data science, in data to make conclusions.
Pretty good. So,
Yeah.
folks, we're reaching the end of this episode. We'll have part 2 in the next episode. So this is episode 21, the first of this season, the first of 2026. The second one will be the continuation of this. And we'll discuss a lot of things like selection, bias, self-reported bias, and some other thing, correctional illusion of explanation. So there's a lot of things, regression to the mean. There's a lot of other topics that we want to discuss next. But before that, you have this great episode with you. I hope you like, share with as many people as you can.
Please do.
And please subscribe to our podcast. Not only clicking the link and listen when someone tells you that we have a new episode, subscribe to it, because then we have a fixed list of subscribers.
Exactly.
And it helps in our statistics. All right.
Yeah.
So,
Stars.
Angelika,
We need 5 stars.
we need 5 stars. Spotify, Apple Podcasts, whatever you get your podcast from, give us 5 stars. There's also it's a lot of help. So
thank you again
Angelika,
for today. Yeah, thanks, man.
Thank our listeners, and see you next time.
See you next time. Bye-bye.
Data